Good afternoon, everyone. My name is Scott Chamberlain. I'm one of the co-founders of a project called Evernode, which is trying to bring smart contracts into the XRP ecosystem. There's quite a few additional slides here that I don't think we need to go through today, but we will go to if we need to later. For you developers, we're looking at a system that allows you, what we're trying to do is build like the most flexible mechanism for building smart contracts in this space. This project grew out of research that I was performing at the Australian National University. I'm a lawyer by background, I'm not a programmer, and I was working with one of the programmers in this space, Richard Holland, who is at XRPL Labs and was the original inventor of Toast Wallet. And when I first received my UBRI grant as part of Ripple's University Blockchain Research Initiative, we embarked on a process of, you say smart contracts can do this. Well, let's put it to the test. Let's choose a use case and try and build a working toy and find out what works and what doesn't work. And the first project that we worked on was one called Self-KYC. We were trying to look at how we might solve digital identity in this space using smart contracts. And all the technology that we looked at didn't do what we needed it to do. One of the ones in the space at the time was one you guys in this ecosystem would be aware of called Codius, which was billed as the XRP Ledger's smart contract solution. The problem with Codius was that it didn't have a consensus mechanism. It did hosting, but it didn't do consensus. So Richard's insight was, look, the XRP Ledger is basically a payment app wrapped around a consensus mechanism. Now, what if you could take the payment app out of that and insert any type of app you wanted? Not payment, but any other particular thing, like the cartridge in an Atari video game. And from out of that sprang the notion of what Evernode could be. And so we ended up with a system that has three key components. There's a consensus mechanism that we call Hot Pocket, which is Richard's penchant for naming stuff after breakfast foods, because he had Toast Wallet, so now we've got a Hot Pocket consensus engine. There's a hosting solution called Sashimono, a hosting daemon. And then we need a layer 1 blockchain, and we're going to use the Zahao ledger to do that, and I'm going to explain how and why. And what we get out of these three things working in concert is a really flexible mechanism for creating bespoke blockchains. What you would call them now, some chains call them app chains. Each of these apps ends up being its own mini blockchain stitched together with its own consensus mechanism. So let's talk about Hot Pocket first, the consensus as an operating system. We begin with a normal app. It has outputs and inputs. It's got rules about how to process those outputs and inputs, and it's got a persisted state. Fantastic so far. Now let's take that app and add a consensus layer to it, which is the Hot Pocket consensus engine. It's UNL based, unique node list, and we now have an app that has a mechanism for it to maintain a canonical shared state with similar versions of itself. And then we take that app and we put it on multiple machines, all of them running the Hot Pocket consensus engine, and now we have our mini blockchain made up of however many machines running the necessary code. And that code, those machines all talk to each other and maintain a canonical shared state between each other. Fantastic. And that's the technology we use to do our, what we called XRPL self-KYC. The problem with this is that, it works fantastically well, but you own all the machines. You've spun up the software on all the machines. And maybe you've got use cases that suit that, but it does mean it's quite centralised. And if you own all the machines, then the question becomes, well, why not just have it on one machine? So we wanted a decentralised hosting solution. And that's the process we call Sashimono. So what Sashimono does is take the Hot Pocket clusters and allows them to run on a Linux host. Now that host is divided into slots. You can see the slots where each of the little Hot Pocket apps go into. Those slots are inside a jail, and then they're inside another jail. The Sashimono agent is then kept separate from the host itself. So all of this is a hosting solution that lets somebody run a Linux machine that can advertise itself as being available to host Hot Pocket apps. And those people, the owners of those apps, or the app itself, can upload itself into a particular slot. And then you upload yourself into whichever of the machines that you wanted, and you stitch them together, and they become a mini blockchain, and you're now running on infrastructure that's not your own, that's a decentralized hosting solution. Now, again, the problem with this is you need to know who's running the necessary software, who is a member of the network, these Linux machines, who's doing the job. So you need a register. Now, that register could be a single machine that Evernode runs, and that would make it, again, completely centralised. You'd have one central point that if it shut down, no one would know who's on the network. So what we needed next was a way to decentralise that registry. And that's what we use Zahao hooks for. Now, I need to back up a bit. Well, we'll get to Zahao in a bit, but it has, when we say hook-enabled accounts, you've heard David Schwartz talk about hooks today. Many of you will be aware of the hooks technology. Hooks are bits of code that reside on an XRPL account. I think of them as effectively ways of automating an account. That hook will assess incoming transactions and decide whether to accept or reject them, and can be asked under certain, if it's prodded, to emit certain transactions. So there are rules for whether a certain transaction is accepted or omitted from an account before that transaction makes it into the ledger. Evernode uses 3 different hooks. It uses a hook that controls the emission of its currency, EVERS, and that hook we're able, those of you who know how the XRP ledger works, you've got your IOUs, your issued currencies. The problem with those is that they're created from your account, and now they've got to reside somewhere, and someone's got to hold the keys to that, and now you've got a treasury, and you're a honeypot and a potential regulatory problem. With the hook, what we can do is we can issue the EVERS from a black hole account, take all those EVERS, stick it inside the account with a hook on it, and that hook emits the EVERS as rewards to hosts in accordance with the rules of the hook, and it's now completely decentralised. We don't control how the EVERS are emitted, the hook controls that. But in this particular case, what we use in the hook, we have a second hook, which is the registry, and that hook administers who's a member of the network. So when a host downloads the Evernode software and runs it and applies to join the registry, what you must do is pay a registration fee in EVERS, in return for which you get a registration NFT. And that registration NFT basically says, it sits in the machine's account on the XRP ledger and says, we are a member of the network. And the hook then controls the redemption of those registrations as well. So in effect, the network is nailed to the ledger. And because it's controlled by hook, and because it's a hook on a layer 1 blockchain, now that registry is completely decentralised. You can't come to, no one can turn up at Scott Chamberlain's home and ask him to shut down the network or to destroy the registry. It's sitting there on a layer 1 blockchain, and it's now as secure as the blockchain itself. And I think that's, that becomes a very important element of how Evernode is all put together in order to achieve this. Now, we're doing it on the Zahao ledger. I understand it's a hard word to pronounce when you look at it. Zahao, it's a thing that names have got X's in this space. When we started this project, we planned to launch this on the XRP ledger. And as preparation for launching it on the XRP ledger, we were able to secure an amendment to the XRP ledger where the multi-sig list was increased from 8 to 32. And we needed that because when a contract runs on Evernode, it needs an XRPL account, or it needs an account on its layer 1 blockchain, because it needs to pay for itself. It needs to pay for the Evers, it needs to pay a little bit for transaction fees, and that it needs a wallet to be able to do that. And you want that to be as decentralised as possible. So we increased that to 32, which was fantastic. We also expected that the hooks amendment would make its way onto mainnet, and it increasingly became apparent as hooks developed that hooks was not going to make it to mainnet for various reasons. In particular, hooks are very much more expensive than traditional XRPL payment transactions. Hooks are also dynamically charged. You have to pay more depending on how complex the hook potentially is, not the thing it's actually doing, but all the things that it might do. You have to pay for all those things, even if you're asking it for it to do only a tiny thing. And so that introduces breaking changes into the layer 1 chain. And so we've ended up, Zahao, in order to get its hooks technology launched, is launching it on a separate sidechain, and Evernode is going where hooks goes, because we need hooks. So what we get out of the Zahao ledger, it's XRPL DNA, so all the benefits that come with the UNL consensus mechanism that the XRP ledger runs. It's fast, it's cheap, you get finality from your transactions. It has the hooks amendment. The Zahao ledger will come with a burn to mint link back into the XRP ecosystem. One of the other benefits we get is integration. The last thing we wanted was to have to launch our own layer 1 chain called Evernode. That would have been a huge undertaking, involving wallets and all kinds of other bits and pieces. By doing this on another layer 1 chain, we get the benefit of all the existing infrastructure, things like Zum Wallet, for instance. We get the security because it's a separate chain. We don't have to try and find our own way to launch a chain and deal with UNL consensus, very difficult. And we get it as decentralised as possible. There is, for us, we explored being able to run Evernode on the XRP ledger with just a multi-sig account for the registration process. And the problem we ran into was that the big benefit that hooks has is that the hook is assessing the transaction that comes in and can reject it on the basis that it's malformed. So if you want to register for Evernode and you send the wrong registration field, there's something that's misconfigured about your registration application, the hook just simply rejects it, and that transaction never makes it into the ledger. It just doesn't happen. And so you've still got your Evers, and we don't have anything from you. If you don't have hooks, what happens, because of the way the XRP ledger works, the transaction happens. It comes into your account, and now you've got something you've got to return, and that becomes quite problematic. It can be difficult, can also be an attack vector. So the thing that we get out of hooks that we really, really need is this capacity for registration, for transactions that we didn't want to have happen to never happen, not to have to send another transaction on top of those to reverse them. What we get out of this architecture is a really hyper-flexible, hyper-scalable mechanism for decentralised smart contracts, or dApps, or app chains. Firstly, you get any language, because what we have is a Linux machine that's running software that provides the consensus as a service, and so you're stitching your single app into a dApp by simply running it on multiple machines. You can choose any POSIX compliant language, so it's an incredible flexibility in terms of the languages that you can program in. You get any functionality. It's just simply a Linux box that's doing stuff in concert with other Linux boxes. So, whether it's read, write data, perform complex computations, connect to external services, Oracle type functions, etc. That's all achievable with anything a Linux box can do on its own, pretty much you can ask your Evernode DAP to do in concert. Any geography, so one of the benefits that we get out of this is you can, for instance, select the hosts that your DAP chooses to run on, and those hosts might be selected by things like country. And for GDPR compliance, for example, that becomes quite important. You can say we only want our DAP to run on nodes that are based in the EU, and now you don't have some of the compliance problems that comes with the GDPR in terms of cross-border sharing of data. And you get any scale. You can choose to run, whatever it is it 3 machines, is it 5 machines, is it 20, is it 50? What level of security are you seeking from your DAP? That's up to you to choose. Obviously, the more machines you run it on, the more expensive it is because you've got to pay for hosting on those machines. In terms of the scale, the other type of flexibility that we get out of that is, I had another point I was going to make there, but it is this incredible flexibility as to the choice of how complicated the system is for your particular DAP. Some of the examples of the use cases that we have developed. We have a nomadic contract. What the nomadic contract does is it's programmed to spin itself up to go into the beta net and spin itself up on a target number of hosts, say 20 hosts. And having reached that target number, it then goes through a process of shutting down a host and spinning itself up on another random host. So it's this kind of almost virus-like contract that moves around the network rather than being tied to specific hosts. And that's a way of, that's a kind of an interesting use case for when you want something that isn't going to be dependent on specific hosts, but dependent across the whole network. Our XRPL self KYC, when we programmed that was a solution where you scanned your identity documents. They were encrypted, they were stored in the smart contract, and then the smart contract delivered them through an API to a regulated identity service provider, one of those, the sort of people that assess your documents and your selfie and come back with your identity. And that would return a confirmation that this person exists, and that confirmation was tokenized, and that token went on your XRPL account. And so no one knew who you were, but they could look at your account and see that that account must be owned by a verified individual because there's a token on that account that says this person's been identified by this identity service provider. And then you had the ability to issue one-use private keys that would give other people access to the document. Now, they request, we want to confirm your identity, would you please give us a key? And you would give them a one-use private key that would expire once they'd looked at the documents. And all of that was handled, inside a hot pocket cluster. We have demoed an EVM cluster. So this was a project running on the beta net where you could upload Solidity code to a contract running on Evernode, and it would run as though it was a contract running on Ethereum. And we have a decentralized hotel booking service. If we've got Ravi, you're in the, so in the audience is Ravi, who's the CEO of a company called GVO. The way that this project's been structured as a research initiative is there's myself and Richard Holland as the driving architects, and then it's Ravi's team at GVO who's built the actual system, and they've developed a use case of decentralised hotel booking. So what you've got is booking.com without booking.com in the middle. The booking.com function is being run by an Evernode smart contract that allows for people to book a hotel, exactly the same process as hotelbooking.com, but without the 30% fee. I think he's factored in a 2% fee that allows for the smart contract to continue functioning, etc. So a really interesting use case in terms of smart contracts. We have another project that we're working on called Digital Cows, which is tokenising Australian cattle, again relying entirely on Hot Pocket. And the benefit of that is that all the data around the cow its photo, its attestations, all of that sort of stuff can be held inside the smart contract itself.